Hello students, welcome back. Let us solve one more good problem from Csir-Net exam. So this problem came in Csir-Net June 2013. So here they have given you a two-dimensional infinite square well, and they have also given you the eigenfunction for this system. So the eigenfunctions are given, and now they say if a perturbation is applied between 0 to a by 2 limit, both in x and y direction, constant perturbation, then what is the correction to the first excited state? So for ground state, you have nx is equal to 1, ny equal to 1. And for first excited state, you have nx 1, ny 2, or you can also write nx 2, ny 1. So this is the degenerate, first excited state degenerate. So you need to apply degenerate perturbation theory. So let me write now functions. First excited state two functions with same energy. So the function is, I will write say psi12 nx1 for nx1 and ny2. The wave function becomes 2 by a sine pi x upon a and sine 2 pi y upon a. This is psi1. Let me call this as a psi1. And second function psi21. Okay, psi21 will be 2a sine 2 pi x upon a and sine pi y upon a. This is for nx2 and ny1. So we have these two wave functions, and now we need to calculate perturbation. We have to calculate the matrix element of the matrix element for h dash. So let us calculate the matrix elements. So I need now h1 dash, that is h1, that is psi1. Psi1 is my psi12, h dash psi1. Similarly, I want now h12, that is psi1, h dash psi2, and h21, that is psi2, h dash psi1, and h22, which is psi2, h dash psi2. So let us first calculate h11, h dash 11. So that will be equal to h dash is v naught, and psi1 I already told you psi naught is your 2 upon a. So we have now, because your wave function is psi1 is this one, psi1 2a upon sine pi x. So now what we can write? We can write 4 upon a square, 4 upon 2 by a, 2 by 4 upon a square, and perturbation h naught is v naught, and then psi1 square. So 2 by a square, 4 by a square already we out. So this becomes sine square pi x by a and sine square 2 pi y by a, and the limit is 0 to a by 2, because perturbation is 0 between a by 2 to a. So we have to only solve the integration between 0 to a by 2 dx. Now let us solve this. So this gives me 4 v naught a square 0 to a by 2 sine square pi x by a. I can write 1 minus cos 2 pi x upon 2 dx, and then you have 0 to a by 2. This I can write 1 minus cos 4 pi y upon 2 dy, and let me solve now this one. So this integration 0 to a by 2. Okay, so I'm solving first this integration 1 minus cos 2 pi x. We have solved this earlier also many times. So this is pi x. So pi x here also 2 pi y by 2. Okay, because 1 minus cos 2, 1 minus, and this is a also is there. So this is a here, 4 pi by a 2. Now 1 minus cos 2 pi x by a, and 1 by 2 is here. Now let us integrate this one, 0 a by 2. So this gives me 1 by 2. This will be x sine 2 pi x upon a, and you have a 2 pi a, limit 0 to a by 2. So this gives me 1 by 2. If you keep here x, so this become a by 2 minus, you put a here, a by 2 pi 0, 0, 0 pi. So this gives me only a by 4. This gives me a by 4. Now, similarly, if I solve this one also, okay, you see this integration does not depend on this 4 pi here, 2 pi here, 4 pi, but this integration only depends on this x. So similarly, if I solve this integration also, this will also give me a by 4 only. So total become, so if I solve now the matrix element will give me 4 v naught upon a square, a by 4, a by 4. So a square cancels, 4 cancels. So this is equal to v naught upon 4. Okay. Now by symmetry, because these are all the real functions. So if I take psi1 h11, or I take psi2. So psi2 is what? Psi2, and there is a 2 pi x. Psi2 is what? Here, instead here you have sine pi x, here you have sine 2 pi x and sine pi. So by symmetry, I can say my diagonal elements, this will be also v naught by 4, because these are all real wave functions and symmetry. So now we have to only calculate h12 and h21. Those will be also same. So let us first calculate h12. So h12 is what? H12 again, you have the function 4 v naught upon a square, and this time you have a function 0 to a by 2, 0 to a by 2. You have a function h12, so you have a sine pi x upon a, and you also have a sine 2 pi x upon a, and then you have a sine pi y upon a and sine 2 pi y upon a also there. So now we need to solve this one. So let us say this is equal to h12 equal to 4 v naught upon a square, and I'm only showing 0 to a by 2 sine pi x cos 2 pi x. So this is this. So we can open this by cos formula, cos a minus b. So cos a minus b. So 2 pi minus theta. So this will be cos theta. So pi x by a minus cos 3 pi x upon a. Similarly for here also I can open 1 by 2, 1 by 2. So 1 by 2, so become 1 by 4. Total become 1 by 4, and this become 0 to a by 2 cos pi y upon a minus cos 3 pi y upon a dy, and here you have a dx. So let us solve now this one by symmetry. This will be also same. So you have now V naught upon A square, and I'm solving only this one. So cos pi x becomes sine pi x by A, and then you have pi by A also here. And here you have a sine 3 pi x upon A, and then you have a 3 pi A also here, and put the limit 0 to A by 2. This will be same like this one. So now I have V naught upon A square. If I put A by 2 here, so A by 2, so pi by 2, so this will come A by pi, okay, minus, here you put here A by 2, so A cancel 3 pi by 2, so 3 by 2 minus, so this become plus A upon 3 pi, okay. If you put 0, everything becomes 0. So now what is coming? This is coming V naught A square, and this term is coming, if I take 3 pi common, so this comes me 3A plus A, that is 4A by 3 pi. And similarly, this time will also give you 4A upon 3 pi. So A square will be cancelled. So you have only 4A, this becomes 16. A square cancels, 16 upon 9 pi square. So you have V naught by 4 and V naught 16 by 9 pi square, and these two elements are same. So now I can write my matrix. I can write my matrix V naught by 4, V naught by 4, V naught by 4, and then you have a 9 V naught upon, let me check what is the 16 V naught 9 pi square. So 16 V naught 9 pi square, and you have a 16 V naught 9 pi square. And now this is my matrix. Now if I find a perturbation, okay, so if I find the eigenvalue matrix for this one, so this will come V naught upon 4 minus lambda, and then you have 16 V naught upon 9 pi square, 16 V naught 9 pi square, and then you have a V naught upon 4 minus lambda equals to 0. And if you solve this one, V naught upon 4 minus lambda square is equal to 16 V naught upon 9 pi square is whole square. And if you solve this one, V naught 4 minus lambda will give you 16 V naught 9 pi square, and lambda will be your V naught by 4 plus minus 16 V naught upon 9 pi square. So, and if you solve it a little bit more, so lambda will be, if you take V naught 4 common, this will be 1 plus minus 64 9 pi square should be the answer. So let us check the answers. So V naught by 4. So B is the correct answer for this question. So this is the solution. Hope you like the solution. Thank you very much.